Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, lots of good information coming your way, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it on demand later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time today you have a question during the webinar, you have a question that you want to ask our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's presentation. Okay, with that, we're going to go ahead and kick off today's webinar, which is Gary Gruver, building quality into the software development process. Our speaker today is Gary Gruver, who's president of Gruver Consulting. We've also got Jeff Keyes, who's product manager at Plutora, on the webinar here. So Jeff, I know you are going to be doing the great big introduction, bigger than my Gary Gruver introduction. So I'm gonna...
I don't know how you top that one, but that's,
well, that's true.
Pretty impressive.
Well, you work with what you've got, right? So I'm going to put myself on mute and let you get right to it.
Love it. You're in for a treat today. I love this topic. Gary is an advisor to Plutora. Plutora is a value stream management solution, and you might be wondering, why are we talking about engineering the digital transformation? As a solution, this book and this process and the topics that we're going to talk about fit really nicely into the whole aspect of walking through digital transformation. And these concepts will dramatically change how you deliver software. We're all here for the same goal. Use this book as your methodology for implementing the change, specifically how do you build quality in the solution into your development process, and use Plutora to help measure and manage that. Without further ado, I want to have Gary go through this topic simply because it's, as we were talking about it just before we got on here, Gary commented, this is where the rubber meets the road, and it really is. Where you'll find your most dramatic changes in your deployment pipelines is when you start to implement these kinds of things. And without that, Gary, with your years of experience of doing consulting and your time at HP, really looking forward to this.
Thanks, Jeff. Thanks for having me. Hi, everybody. Get some great questions going for me because a lot of the value of this goes on how well we have good questions at the end. So I appreciate your input.
That's absolutely right. We didn't talk about that. There's a little question panel. There'll be a fair bit of time at the end to talk about the problems and areas you've got. So get in there. Don't be shy. We'd like to grab these questions and tackle them as we go, or tackle them at the end. So as you go and you think of things, put them in the question box.
Do you believe that how effective your organization is at developing and delivering software matters to your company? When you look at how you're developing and delivering software, do you think there's a lot of opportunities for improvements? But as you go out into your organization, you struggle to get people aligned and on making the improvements and committed to changing the way you do development on an ongoing basis? If you answered yes to those three questions, you're like most of my clients that I work with out in the organizations that really understand that software is becoming more and more in terms of how they compete, and that they're not as effective as the Googles or the Amazons or the Netflix of the world, and they need to get better, but they just can't quite get there. They're so busy spending their time cranking out the next business idea that they don't spend a lot of time and energy focused on the process. If anybody knows me, ever since I had this opportunity to lead a large-scale development at HP where we got an easy 2 to 3x improvement in productivity, my passion has been all about how do I help others improve? How do I help others see the benefits and the breakthroughs that we saw at HP? I do that through webinars like this. I do this through workshops at the clients and coaching them on an ongoing basis, and I do it through books. And books are really a pain in the rear to write, and they take a lot of effort, and as an author you don't get a lot of return from it. And I swore to myself I was never going to write another book. And then last fall, I was on a trip through Europe and debating on marketing events with a lot of people that were on their journeys about how best to approach this. I had several clients. As I do workshops, I stay engaged with clients for a long period of time to help coach them on the journey. Then I was watching them struggle to make the progress that I really felt that like they needed to make. And I started to come to the conclusion that we needed a more systematic approach for how we do improvements on software development and delivery. And it can't just be, implementing the latest Agile or DevOps practices and hoping that we get business results from it. I grew up as a process engineer in manufacturing, and there was a more systemic approach that we had there. As I started having this debate with different people at DevOps Enterprise in London last year, people were saying, yeah, we need to do exactly what they did in manufacturing. And as somebody that grew up in manufacturing, one of my biggest ahas when I moved to software is it's different. You can't do what you did in manufacturing. We can learn from them, and we need a systematic approach, but it needs to be fundamentally different. And I, took the time over the winter to really capture that, help people understand, here's what happened in manufacturing, here's how software is different, and here's a systematic approach that we can use for driving continuous improvement in our organizations. Captured that in my latest book, Engineering the Digital Transformation, and did that. We're doing a series of these webinars with Plutora. The first one was an overview of the book. Last month, we did a deep dive on architecture and the impact that it has on the deployment pipeline. This week, we're doing a deep dive on building in quality, because I fundamentally believe that's one of the key breakthroughs that's happening in the software industry now. Next month, we'll focus on flow. The month after, continuous improvement. We're continuing to go down this journey to really do deep dives in the different areas to help people understand what they can be doing and how to drive these changes in organizations. One of the things that manufacturing learned early on is that if they were going to be efficient and effective at manufacturing and really improving their productivity, they couldn't inspect in quality. They needed to build in that quality on an ongoing basis. Edwards Deming was probably the father of the quality movement. There were others in the area, but he went to World War II, or went to Japan after World War II, and really spent time consulting with their manufacturing organization, and took Japan from a country that was known for low quality, cheap products into a leading manufacturer in the world, and then came back to America and was recognized and really started leading that change here. From a perspective of what we can learn from manufacturing, I think the key thing is they created a whole culture around building quality in. It was an approach, it was a realization that they never could be effective. Software, we really haven't taken that shift. A lot of organizations build up large batches of inventory to inspect in quality in a phase that they call hardening, or the end game, or whatever it is, but they'll build up batches of inventory, and then they'll inspect in quality. And this is just not something that you'd ever do in manufacturing. They learned decades and decades ago that this is just an ineffective way to work. When they looked at it from a manufacturing perspective, a lot of what they did is they were trying to build the same product over and over again with as little variability as possible, and the process was creating the product. So they created process control charts, and in this situation they measure a tolerance or some aspect of it, and they track the natural variability of that, and if it went out of control limits, then they knew they had to respond to something. And this is the approach that they used in manufacturing, because the process was creating a product. This is where software is very different. And software is not the process that's creating the product. It's individuals that are creating the product. And these individuals are doing creative work, they're writing new code, and we're not trying to manufacture the same thing over and over again. And in fact, every time a developer checks in code, the products change. So what we need to think about in terms of building in quality is not controlling the process, but we want to be giving feedback to those developers as real time and frequently as we possibly can. We want that feedback to be high quality. We need that feedback to be something they can react to, something they can learn from. This can be unit testing, this can be system testing, this can be security testing, this can be any type of testing that you need to be doing. If you want your developers to get better and be more effective, we need to be giving them that feedback on an ongoing basis. And as I work with organizations around the world and we start trying to implement DevOps and they start trying to, build on a more frequent basis and respond to that feedback, one of the biggest challenges I see is that people get ahead of themselves. They get going down this process and they're asking their developers to respond, and they don't yet have a stable quality signal. And I've seen more organizations start down this path, start to ask their developers to respond and react, and what it turns into is an exercise of frustration. You end up having developers going in and debugging and triaging things that they can't fix. It's not feedback that's useful. It's not feedback that's effective. And I finally gotten to the point that, one of the things where I say we need a more systematic approach to improvement is if you're going to change the flow or how you do things on a more effective basis, the key to that is having high quality product and building in that quality. And the first step is a stable quality signal. As we look at that, one of the first things I do when I go into organizations, if they have some automated testing, is I'll go in and I say, okay, let's take 20 of your, let's take your automated tests and let's run them. Take an environment that is good. Don't change the code. Don't change anything. But let's take those and let's run all of our automated tests 20 times in a row and see what kind of answer we get. And very frequently I get this type of result. You run those tests 20 times in a row, you dump them into a database, you look at your test runs, and you'll see some tests that are always passing. You'll see some tests that are always failing because they have a defect. But very frequently, what I see is there's a lot of tests that are flaky. They're toggling between pass and fail during those 20 runs. If you're going to ask developers or anybody else to go debug and triage these things and you have a lot of tests that are inconsistent, you're not going to have any success in terms of being able to ask them to respond to it. They're going to be debugging and triaging stuff that's not related to their code. They're going to get frustrated. They're going to give up, and your whole transformation is going to grind to a halt. You're going to have an insurrection from your development organization because this fundamentally isn't working. And one of the first steps we want to do is we want to take all of the tests here that are failing and remove them from our test set. We want it until we get the defect fix that's associated with it, and then we can add them back in. We want to take any flaky tests out of the system, and we want to have a set of tests that we can use to analyze our quality signal and make sure it's working. We're doing this in a systematic way because we want to get to the root cause of the issues. And if you have tests that are flaky, they're not going to be effective. As I do this and I go into organizations and I ask them to remove those tests, what I frequently get back from people is, well, wait, we can't get rid of those. They have good code coverage. And I argue that, if you have flaky tests that people are sort of not getting the right answer about their code on, having them still in the system that you're asking people to respond to is worse than not having them at all. So the first step that we do is we remove those. And if you leave the flaky tests in, what you're training your developers to do is ignore their signal, and you're creating frustrations. The next thing after we've gotten a set of tests that we think we trust is we're going to go through a step-by-step process of trying to figure out, are all the pieces of our deployment pipeline stable and ready for a quality signal? So we talked about, we selected an environment, we ran this validated test for repeatability, and we dropped them in there. Now the next thing we want to do is we want to be able to run these tests in random order and see if we get the same answer. And frequently you'll find when you run them in random order, you get an additional group of flaky tests because people have designed them that way. And the reason we run them in random order is because we want to be able to put them in parallel. We want to run them against the system on a regular basis. And if the test before it set up the test after it, and you can't randomize the order, then you can't run them in parallel. So we need to make sure that they can be run in random order. And when we run them in random order, we still get passing. If we come up with more flaky tests, we need to set them aside for rework. Now that we've done this, we've ensured ourselves that we have a set of automated tests that we can validate the rest of the system with. We can run them in random order, and we've got some quality tests. As I go into organizations when we run these experiments, I have yet to run into an organization that didn't have to do a significant amount of rework to their test framework and their automated tests so they can be effective. And before you ask your organization to be responding to the feedback from these automated tests, you need to ensure that you've got a stable quality signal. The next thing that we need to do is we need to ensure that our environment is stable under load. And in this case, what we do is we take these automated tests and we run them in parallel against the system and see if we still get a stable answer. You know, are we all getting all passes and all fails, or are we getting variability? And I've seen this be the demise of more transformations than you can possibly imagine. You would think these tests would run, but typically these environments have been created when there's a lot of manual testing going on in them. And as you've made the transition to automated tests, you start to load them up and it can be a problem. I've seen organizations that have flaky F5s in the system, and it's just randomly throwing out failures. And when you ask the development organization to debug and triage it and they can't find anything because it's random out there, you're gonna crater your transformation. I've seen organizations that have 3,000 or 4,000 tests. They run all the tests automatically on Monday, and they don't run them again the rest of the week. And when I asked him why they don't run them the rest of the week, he said, well, 40% of the tests time out, so I have to spend the rest of the week trying to figure out which ones are real failures and which weren't. In this case, you needed to increase the CPU and the RAM associated with those test environments so it didn't time out. There's organizations that have had bad connections to their Git servers, and then that caused it to where they the builds would have problems. Really take the time to load up that environment with a set of your stable tests and ensure that it can handle the load and go through that process. Once you have an environment that is stable and you've removed all the intermittencies out of it and you've gotten that, what we want to do next is ensure that our deployment process is stable. In this case, you take the same version of the code and the same environment, but you deploy it and then run the test, deploy it and then run the test, deploy it and then run the test. Do that 20 times in a row. And if you get the same answer, then your deployment process is consistent, it's reliable, it's stable, and that you can continue to rely on that and trust that. If that's the case, then the next step is you're going to create an environment, run a deployment, run the test, create an environment, run the deployment, run a test, and ensure that you can create an environment consistently, reliably on an ongoing basis. This process of going through and figuring this out and figuring out where the instabilities are, it can be a significant journey for a lot of organizations. There's a webinar that we did with Plutora, I think last fall, with Ted Ewell at Optum, and I've worked with him for 2 or 3 years, at least, a little more than that now, and he went through this process, and it took them that amount of time to really get all the instability out because he was working in a much larger system and he got a fundamentally stable quality signal. And when you do that and you can ask people to respond, it fundamentally completely changes how you can do software development. And listen to that webinar if you can. I'm sure it's still out there at devops.com and on Plutora, and it can help you understand just just listening to the passion in Ted's voice as he finally got this stable quality signal and how it changed how it worked was kind of his aha moment for doing this. But These set of tests are designed to help you understand the types of instability in your system that are causing inefficiencies that you need to address. And I would say each different applications or set of applications, deployment pipeline in your organization probably has different sources of instability. And if you're going to drive the improvements that you need to drive, you need to address the challenges that are very specific to those applications and those pieces. It's more than just a maturity model or saying, hey, you know, people who did DevOps did things in this order and those were the ones that were more successful. What I find is I go into organizations, you need to address these things in this order. And this can tell you whether you need to work on your test automation, whether you need to work on your deployment automation, whether you need to work on your environment stability, your environment creations. Each of those different types of pieces is what this experiment is designed to do. And it's going to be different for different deployment pipelines. And this process of running these experiments will prioritize the things that are getting in your way. And as you fix these things, this is waste and inefficiencies that's currently occurring in your organization. What's happening now is it's happening at a low enough frequencies that people can brute force their way through the problems and deal with it. And as you start to ramp up the frequency, these things become much more visible, and we need to fix them once and for all through automation. Another approach that we can take to figure out what the issues are is doing a good job of tagging our tests in terms of our defects in terms of the source of problems. You know, and we can create a Pareto chart for our defects to figure out whether they're test issues, environment issues, deployment issues, code issues, data issues. This is the type of information that you need to prioritize the things that you're going to go fix and the things that you're going to work on. Once you have a stable quality signal, and it doesn't have to be, you know, 100% coverage to be effective and help start helping the organization. I see a lot of people say, well, I can't really depend on my test automation yet because I don't have full coverage. I need to focus on full coverage. My experience in working with organizations is it's much more important to have a stable quality signal. And then when you have that, you can start improving the base level minimal quality that you'll allow in a situation. At Macy's, we started with 5 automated tests and started getting the development organization used to keeping those green. And then over time, as we got more stable, we could add tests. And if you're going to start down this journey, one of the first places you can start with for your basic level of quality that you want in is go to your QA organization and say, when you do manual testing, what are the types of things that you see on an ongoing basis where you know that if you get an environment that this doesn't pass on, it's not worth wasting our time doing anything else with it. Take a few tests, add your automated tests, make sure that, you know, they can go through this process of being stable and reliable as a quality signal. And when you get that done, start with a few tests, because your development organization is going to take a while to get used to keeping these builds greens, become effective, and work through that process. And if you dump, you know, 3,000 tests on them that are flaky, it's just going to impale. If you start with 10 automated tests that everybody's clear should always pass, are reliable or stable, you can get them used to doing that, and then you can add more tests over time. And what we're trying to do is we're trying to get them to respond to this quality signal. And software is unique in that when we have a failed test, that is, I call them our build acceptance test, some people call them smoke tests, but this is a subset of your tests. It's the smallest, it's the minimal level of quality that you're ever going to allow in your system, which is to say, if it doesn't pass, then that's a red build. And I hear a lot of people in the community talking about, well, yeah, this is just like pulling the andon cord, and what we do is we stop the process and we don't let the process go until we get it fixed, because that's how they did it in manufacturing. And in manufacturing, they stopped the process because the process was creating the problem. In software, we have this unique capability where it's not the process that's creating the problem, it's a developer that wrote some code that had some unintended consequences. And what we need to do is provide that feedback to the developer. And with gating of the code, we can use a process to say, we don't have to stop the line. We can just take the bad code and send it back to the developer to get fixed and remove it, and then open the gate back up and keep the code flowing. We don't have to stop it. We just have to take all the new code that was committed in that build and send it back to have it fixed, whether it's here at the gate, at the code check-in, or it's at the application check-in to the broader system. We can gate that code. And what happens is when we start asking people to respond to sort of this and that their code's going to get rejected, if we don't have a stable quality signal or we add too many tests too fast, you're going to end up with frustrations and people are going to give up and it's going to get difficult. And the idea here is with software, because it's not the process creating the problem, it's a developer. What we want to do is give them the best quality feedback we can possibly give them as quick as possible so they can fix the code that had the unintended consequences that they didn't realize. And we can gate this code, here at an application at check-ins. If you have a large, complex, tightly coupled system like we talked about last month, you can gate the code as it goes into the QA organizations, each of the subsystems. And what you're trying to do with these gates is you're trying to find and capture the defect as close to the source as you possibly can for a few reasons. One is that it's the most rapid feedback you can give to the developer. You can give it to them while they're working on the code, while they're checking it in. Two is it makes the triage much easier, because if you can gate it here, it's one of these check-ins, one of these applications. And then three, if you've gated the code and you've captured the defects back here, then when you go to do your manual QA testing, it's in a much more stable, it's in a much more reliable environment. And as you go further to the right in the deployment pipeline, then you're able to ensure that those are much more stable on an ongoing basis, and you've got the reliability there. And we do this with the gates, and we get started there. Like I say, one of the best places to go is to go to your QA organizations and say, what's the minimal level of quality that you'll run in? And then start to add those tests over time. Even as you have a lot of automated tests, at some point you're going to get to where there are more automated tests than you have time for the feedback cycle here. So you want to give feedback as quick to the developers as you can, and you want it to be high quality. But if it's taken a really long period of time to run all your automated tests, you can't run them all on every check-in and at every gate. And in this situation, what we do is we separate our automated tests into a group of tests that are associated with, gating, and we're going to call those our build acceptance tests. And we have the whole rest of the tests that we'll call regression tests, and that's a full set of our automated tests. And what we want to do is we want to take the latest green build each day that's made it through the gates, and we want to run that through a full set of regressions. When we do that, we need to put this data in a place so we can analyze it, because what you'll find is when you end up with a lot of automated tests, you cannot effectively debug and triage every test every single day. You'll get overwhelmed by it when you start really ramping up the frequency. And what you need to be able to do is statistically analyze the results. So for the regression test results, what we're doing here is as we go across the builds, we need to drop those into a database that enables us to have a visual view of what's going on. And we also need to label our tests effectively. We need to label our tests so that it's pretty clear the team that should take the lead in debugging and triaging these. And in this situation, as we watch at this graph, we can see here on this test label 4, that between build 4 and 5, there was a significant drop in the test passing rates. Now in this situation, these defects were not caught by our build acceptance test, but it had a significant drop in here. And what we want to do when that happens is we want to take one of these tests that was able to catch the defect and move it from our regression test and add that to our build acceptance test, get the defect fixed, add it to the build acceptance test, and then that'll help drive up the passing rate again over time. And over time, what you're doing is you're using your build acceptance test to build in quality. You're using your product control charts to find holes in your build acceptance tests. And what you do is over time, you add tests to your build acceptance tests that are covering holes, and you remove tests from your build acceptance tests that aren't finding things because you're trying to keep the timing down. So it's a trade-off with your build acceptance test for how long they need to run and how much coverage they get and what they're really finding. And that's your most valuable tool for building in quality. And you need to be able to look across that and look across the systems and how that works. And then when you have a drop here and you have a team responsible for figuring out how to get that fixed and how to make sure that that's resolved, you need to make sure that your tests are labeled in such a way that, you know, that's the checkout team that's responsible for that. The checkout team knows they have a hole in their build acceptance test and they need to add that, and they're going to need to take the lead for triaging it. If you've got, you know, tests that are failing and they're labeled here, but they're broken because the homepage is broken, you're not going to have very good success because people are going to get frustrated coming in every morning and checking them. So the key to making good product control charts is making sure you have the data, putting it in, but also making sure that it's labeled correctly and making sure that people are really, you know, going to this process of gating it, understanding where to gate the code. That's how you build in quality. This is how you find holes. You can also continue to talk to your QA team and say, what are the types of things that you're seeing that we should be finding, and going, you know, down here, out from all the way out from production to staging, look at areas where we're finding defects and look at opportunities to plug those holes with gating as we go forward. The build acceptance test is one key piece of information that we use for that. The next thing that we really want to know about is the, you know, when we go from environment to environment, do we have a problem when we went into UAT with test label 5 that shows when we went to here, we really had a significant problem with our UAT testing. Maybe we had a back-end system that was broken, maybe something else. In this situation, you don't want to go in and debug and triage every single item and figure out exactly what is going on. You want to be able to look at it from a high level and look at, you know, hundreds or thousands of tests at a time and enable you to localize and triage that, because what we're doing is we're running tests much more frequently, we're running much more often, we're running a much higher volume of automated tests, which is really good. But if we still do manual debug and triage the way we've traditionally done it, we're going to get overwhelmed by that process. So we need a database, a system that enables us to look at this data and figure it out. The other unique challenge that's out there with software, and I don't have a slide for this, is in manufacturing, you're trying to make the same product over and over and over again. In software, every time we check in code, we've changed the product. So once we have a stable quality signal and we're able to analyze it and we're able to really increase the minimal level of quality that we have by farming our bat tests and adding the right ones in, our next challenge is how do we make sure the process changes at the rate of the product? A really good example of how this is done is containers for the environment. Whereas if a developer wants to change or needs to change the environment, they do that in the container while they're doing the development. The code and the environment specification are encapsulated together, and they move down this deployment pipeline as a system, and it works together that way. The challenge that we have for testing is we need to understand how do we couple a change to the test with a change to the code to ensure that those two things are aligned. And how do we effectively real-time realize that when we change the product, knowing what tests need to change. That same challenge is out there for databases, but once you get down the road of having a stable quality signal and starting to increase it over time and getting people used to it, the 201 version of this is, how do we start evolving the process to change at the rate of the product so we can maintain a stable quality signal and we can really be finding the right things. The steps here are really what's designed to build in quality. Once you can build in quality and capture the defects at its source and get real-time feedback to developers, you can really start to increase the flow and frequency that you're able to deliver and do these types of things. And if Deming had to come back and look at how we're doing software development today, where we batch up large amounts of inventory and inspect in quality later, I don't think he'd be that proud of what we're doing, but there's real opportunities to fundamentally change that with automated testing if we take the time to get a stable quality signal, build it up over time, and use our product control charts to figure out where there's holes in the build acceptance test and continually improve this as we move forward. This, I think, is fundamentally one of the biggest steps you can take to systematically improving how you do software development. And with that, I'm going to hand it back to Jeff, and he's going to go through a couple slides, and then we'll get back to a Q&A session. So, start stacking up those questions. So I think we have time for some pretty good discussions here.
We do have some good questions in here. Just to comment, why is Plutora having this conversation with Gary? We are a platform to help you manage your value streams. We have a way of pulling that data in. Every time Gary said, and throw that into a database, that's where we fit in. We can correlate the data across your tool chain all together, aggregate it, provide an analytics engine on top. We also have management and orchestration capabilities to help you through this. Managing value streams has the goal primarily of building high quality software faster and improving the delivery and the process itself. That's what we're talking about. On the next slide, if you don't know much about value stream management, go take a look at the Forrester Wave. You can get it on our website, and it'll give you a big walkthrough of why. But use Plutora as your system of measurement, system of providing measured outcomes in your delivery. As you make all these changes, you can use Plutora to help in this process. And with that, there's a bunch of questions that I want to get to. If you go to the next slide. Actually, the first one, there's a few questions actually on this, Gary. Back on your deployment pipeline, people were getting a little bit lost on the, I think it's your slide 10. They were getting a little bit confused on the frequency. There's a few questions on the frequency of the deployment pipeline, on the frequency of builds that run in each place and the kinds of builds, because you talked about running build acceptance, and then you talked about the different regression tests. So I think I've got a number of questions that are all about this. Can you talk about, just summarize the timings, the kinds of tests that are run here?
Yeah, your build acceptance test, ideally that's unit tests that check in, but the reality is a lot of organizations I work with just don't have that many unit tests and don't have that good of coverage, and they get better coverage quicker with their system tests that they have automated. So, this can be a few, and you can check it in when a developer checks in code. You can have build acceptance tests at the application level. You can have it at the subsystem level, and this is probably a good one for people who missed last month's webinar to go back and watch that one, because it talks about how you take an architecture, build it up into a deployment pipeline, and have these different pieces. You can have this at the subsystem. You can gate subsystems as they go into different environments, and the idea here is, it's finding the balance between making sure you're capturing defects as quick as possible versus this idea of not letting this code integrate together. So typically what organizations have done a lot of times is they hold up a lot of code until they meet some level like development complete, and then they move it into QA. And what you're doing when you do that is you're delaying finding interactions between the three different subsystems. So, you know, you can be doing builds here at, you know, at HP we did 15 of these type of builds a day. And we did a full set of regression once a day on the latest green build. And what you're trying to do is build frequently enough in a small enough subsystem that enables the triage and debug to be efficient. You want to get that down to probably less than 10 developers on every check-in. So it's pretty quick and easy for them to identify who caused the issue. If you get a lot larger in terms of the number of commits, then nobody's going to take ownership for it and resolve it, type of thing. So, you know, the build acceptance, anywhere you see a gate is a build acceptance test, and it can be a build acceptance test at an application, at a subsystem, going into the different environments. And the frequency that you move code through there is going to be based on your ability to keep code at an acceptable level of quality, which is why, you know, a lot of what we talk about in DevOps is how do we efficiently go from check-in to production as quick as possible. And the key to that is, you know, ensuring that you have quality that can flow through the next stages. So in my mind, using those gates to ensure that you have quality and provide the feedback to where it belongs. And you know, if you're constantly breaking these environments where you may still have some more manual testing in it, you're really having some big inefficiencies in the system. If you can use the automated to gate it and keep those environments more stable, you don't have to wait to do UAT testing or QAT testing till the end, because you know that you have a much more stable environment than you typically had.
Absolutely.
Do you think that covered it, or do you think there's more that
There's a couple other, how did you decide where to put, well, there's two questions. There's a question on how did you decide which test to put in a regression test versus build acceptance? How long should regression tests run? And you also, there's another question on, you talked about taking tests out of regression tests if they're, you know, once they're stable, where do you put those tests?
So the flaky tests you can still run, but set them aside and put the data in the database and don't ask anybody to respond to it. So the key is not saying that you can't run it, because it's an automated test that can run, but don't ask anybody to respond to it. And you know, some of those, so you need to tag them or label them correctly that says, I know these are bad tests. And then as you work to improve them, then you get them stable, and they've been proved to be stable for, you know, several days. Then you can move them into regression. The thing that you're going to want to do is the build acceptance test. You can really, as you start to turn this on and you're asking the developers to respond, they're going to need to learn new skills, right? They're going to need to be able to rerun those tests on their desktop. They're going to need to be able to debug them and triage them. And if you start with, you know, 3,000 tests and they check in their code and 100 of them break, they're going to give up. So build acceptance tests start with a small group. And I typically go to the QA organization and say, what are the things that you frequently see that makes this not a good place to be doing your manual testing or anything else? And let's put those in. And you start with that base set. And then anything else that doesn't work, you move into regression. And those are regressions that you think are good tests. And then, you know, you can have another set of places where you have a data and a test label that enables you to say, you know, here are my flaky tests. And you can see if you're improving them over time. And yeah, you still want to run them in the background, but you don't want to ask people other than the people working on the test to look at them. And then once they think they have them resolved, they have them working, they have them passing, then they can move them into the appropriate label and do it that way. Did I get all the questions?
Yes. Another question on integration and code scanning back in your deployment pipeline. Where does that fit? Where do you run those?
I think you want to run everything as far left as you possibly can, and frequency. What we're trying to do is we're trying to get the developers to get better. Every developer comes in wanting to do a good job, thinking that they're doing a good job. And if as an organization we don't provide them feedback on the types of things that matter to us and we think are important, we can't expect them to respond. And what happens in a lot of organizations is they'll batch out code here for days, weeks, sometimes months before it gets over to here. And then they wait till they get out to staging, and then they run a security scan, and there's no time left before it goes into production. And they wonder why they can't get the developers to really respond and care about security. And you're not giving them the feedback when they're writing the code. And by the time you're giving the feedback, you're out of time. And they go to so many organizations that say, nobody cares about security but me, and I'm the only person, nobody respond to it. And it's like, well, when are you giving the feedback? And if you're giving the feedback months after they've been writing the code, how do you expect them to get any better? How do you expect them to improve? If you're the security person and you want them to be making sure none of those vulnerabilities are there, try to get it as close to the code as you can. The other challenge is if you're running that security scan out here and you've got hundreds of people working over here, when a security problem shows up, somebody has to debug and triage and chase it down to the person that causes the problem. The closer you can get it in this direction, the less people you have to hunt through and figure out who made the problem and who created it. And if you can have it happen on the build and the check-in, and there's 10 people in that check-in, and all of a sudden there's an issue, and those 10 people are responsible for resolving it and figuring out what it is before their code can get checked in, they're going to do a very good job of providing feedback to the developer and getting that fixed real time so they can get their code in. It's that process that changes it. So within that, there's the how long does it take and how quick is the feedback. That's the real trade-off. And maybe you can get some basic scans here, maybe you need some other scans here, but if you're delaying your security scans and all those other things, what you want to make sure you're not doing is batching up inventory and holding it for inspection later so that feedback's delayed.
Cool. Keep typing your questions into the question panel. We'll get to as many as we can. We still have a few minutes, so this is great. There's a question on the Pareto chart. When you typically go into organizations and they first create their Pareto chart of the categories of tests, how does that actually look? What kinds of things are you seeing typically?
I'll go into. It's usually primarily dominated by test issues or environment issues. But what I've seen in a lot of organizations is when you really start getting into it, environment issues are frequently code issues. It's just somebody else's code issue. Which is to say the environment looks broken to me because somebody checked in code that broke the environment. Mm-hmm. And in that case, you really need to take the time to gate that code so it's not breaking my environment. And I have yet to go into an organization and have them start gating code and not go back and rework a significant number of their tests. And what I find is a lot of people are trying to force people to respond to automated tests that are a flaky quality signal. And that's to be honest, that's one of the bigger motivations of writing this book, is just stepping back, systematically going through the steps to create a stable quality signal. And if you got the time, go back and watch Ted Yule's journey at Optum, because he really describes all the steps that he took, and those are realistic in a large organization to do these. And then there are too many organizations that I've gone into that when you put the system under load, it's flaky. And the reason it's flaky has not been common in any one, but you really need to load it up and drive those to root cause. And more than anything else, before you start acting people respond, you need to make sure that you can do that piece of it. And you can do it this way. I've kind of liked this way, and I'll go into organizations and start a workshop and do this and have them try to run this experiment. And to be honest, there's a lot of organizations that can't get to step 2. They can't run them 20 times in a row because they got to set up the data for it, or they can't run them 20 times in a row because they can't automatically kick off the tests, or they can't run them. There's just a big group of reasons why, they've got I call them motivated tests, which are manually run automated tests, which
Yep.
that just doesn't make any sense to me. But it's it's been a QA organization that's been responsible for doing manual testing, that's been given the job to automate it because the testing takes too long and costs too much. And they go in and start automating it and start trying to do it, and they're measured on code coverage, because when they get the code coverage up, then they can get rid of the manual testing. But they never start this step of responding to automated tests. And there's a classic example in my book of where, when they first came out with the ERP system, a lot of different organizations rolled out ERP, which is how do you manage a manufacturing floor? How do you know what to build, how to do inventory, all those different things. And Black & Decker rolled out an ERP system when computers first started coming out. And they used to run that new planning system once a month, and you'd have like 40 people for a factory of 300 people to do all the planning and figuring that out. And what they did at the end of it is they rolled out ERP system, and they had lower inventory, better availability, and fundamentally started dominating the market. Everybody else ran out and got ERP systems because of that, rolled it out, but they weren't seeing the benefits. And when Goldratt went in and studied them and figured out what was going on, what he realized is that there was a fundamental rule that was part of the old system that nobody changed or broken for the new system, and that was you ran ERP once a month. Well, when they automated it, what Black & Decker was doing was they were running it several times a week, which enabled them to fundamentally change how the whole organization worked. What I see a lot of organizations doing is they did exactly what all the other people did that did the ERP system, which is they ran it once, they automated it, would make it much more efficient to run, but then they still only ran it once a month, so it didn't change how the organization worked. So instead of thinking about, holding off, changing how I do testing and doing it at these stages of my software development lifecycle, how I do it, we need to look at changing the rules when we have these new capabilities and using this new capability to change how the organization works and run it on a more frequent basis. But to do that, it needs to be a stable quality signal.
Exactly. Well, it looks like we have time for just a couple more questions. How does this process change when you're dark launching features, and what advice do you have as you're building that in?
I think realistically, if you design it right, even if you're dark launching features, your test framework should have access to the new features and the old features, and you should be able to test both paths. So yeah, test those wherever you possibly can, as soon as you can. As soon as you start writing the code, you should be able to start testing against it, and your test framework should be able to access both paths and enable you to do that, and then it's tested when you go turn it on in production.
One more question on testing in production and your thoughts.
A lot of it depends on whether you can control deployment. If you've got a small, loosely coupled team where there's a group of 5 people and you own deployment and you can do canary releases, you can do A/B testing, there's an amount of effort that you put into it up front. If you're doing embedded software for a medical device where you don't own deployment and the consequences of a failure are high, like on a medical device or an airplane, I'd rather not do in production testing. But if you're
generally bad.
if you're my Facebook account and you got a small team and you can do a quick canary release, that's probably more efficient than creating everything up front.
Very cool. Very cool. Well, Charlene, we will turn it back to you. A lot more to talk about. This has been awesome.
Yeah, so lots of good questions that came in. If we didn't get to your question, just know that the folks at Plutora
Oh,
and Gary will be more than happy to follow up with you offline. But I do want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or you just want to listen to it again, that's totally okay with us. You will be receiving an email following today's webinar that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go there. Just go to devops.com/webinar, look in, or webinars, then look in the on-demand section, and it should be right there waiting for you. Jeff, any final words?
You know, I really like this topic because it is transformational to how you build software. The only way to go faster is you've got to get the quality higher. And we see this from a metrics point of view as people are struggling to deliver software, and they come into those questions. Well, I got to fix certain areas of my process. I've got to fix my orchestration. And the concepts we've talked about here are so fundamental. They're so central to how to actually make DevOps work, how to make your pipeline higher quality. And we see it from a high level. We see it from a perspective of here's the metrics that you're pulling in. People go run a value stream map and they see the time that's taken, and they wrestle with what's happening as things go through the QA process and low quality software because things weren't really vetted out beforehand, is huge. So these principles and this methodology is spot on, and I love it, and great advice. So I can't tell you enough to go experiment with putting these practices in place.
the
All
other thing
right.
I don't think we mentioned, Jeff, is everybody can get a copy of my slides by just sending an email to slides@garygruver.info, and that'll have links to the other slides from the other presentations. And if you missed the lead into this is going to be a series, and they play together well, so it may be worth going back and watching some of the previous ones.
Yeah, and you can get all the webinars on devops.com. We'll have an aggregate place on Plutora as well where you can get the links to them all.
Awesome. Awesome. Well, gentlemen, thank you so much for your time. Gary, as always, a great presentation. So thanks for taking the time out and doing the webinar for us today. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.
Bye.
Bye.